Hi, and welcome to our lesson on variables in C programming. You should have read the sections on variables, data types, and declarations in your textbook, Pick Microcontrollers Programming in C by Milan Verli. The first time you heard the word variable was probably in algebra class, where the variable of choice was called x. And if you're like me, you spent an entire school year wondering what the heck x was and why we're so interested in finding it, which leads me to the cartoon that you're looking at. The good news here is that we don't have to find our variables, and we can give them more descriptive names than x. But computer variables are similar to mathematical variables in that their values can change or vary while the program is running. Well, so what exactly is a variable? Well, a variable is just a storage location in memory, and its contents can change while the program is running. Okay? When you bring data in or you're working with any kind of data, it needs to be stored somewhere, kind of like writing down numbers so you'll remember them. When calculations are performed, the computer has to put the results somewhere, so we use a variable for that as well. So these storage locations are called variables because their values can change or vary throughout the life of the program. So here we have two memory locations that hold numbers. Okay? Each memory location has a binary address. Remember, everything in the computer is binary. Okay? But it's easier for us to use names than binary numbers. Okay? If I say to you actual temperature, you kind of have an idea of what that means. If I say to you 101011100010, what does that mean? I don't know. It's just some binary number. So we assign variables names so that they're easier for us to know. So the names are translated when the program is compiled. The names are translated into binary addresses. So when we write software, we write variable names. The computer will translate that into a binary address when it turns into machine language. So when you're planning to use a variable in a program, the first thing you have to do is tell the compiler to reserve memory space for that variable. And you do this by declaring the variable, or a variable declaration. Because different types of data take up different amounts of memory space, the compiler has to know what type of variable you're declaring so it can reserve the correct amount of space. Because we don't want to refer to storage locations as their binary addresses, we declare a name also. So a variable declaration includes a type and a name. Okay? And variable names can't have any spaces in them. So when a variable name consists of more than one word, what I usually do is capitalize the first letter in each word. It kind of serves as a visual separator. So it's easier to see that that's really two words, but I can't put a space in between. Okay? And variable declarations always end in a semicolon. Okay, so if you look at this, what you see is that my data type is a short integer. And my variable name on the first one is desired temperature. Okay? My second one, the data type is also a short integer, and this variable is called actual temperature. Now, why did I choose short integer type for these variables? Well, if you go back to your textbook reading and you look at the different types of data, you'll find that a short integer can hold numbers from 0 to 255. Now, since we're dealing with temperatures inside a house, I'm kind of assuming that the temperature inside your house will never go below 0 degrees Fahrenheit, and I'm assuming that it will never go above 255 degrees Fahrenheit. I think those are pretty reasonable assumptions. Okay? I'm not concerned with fractions of a degree, so I don't really need a floating point number. I don't need a decimal point. So an integer is a whole number, and because I'm sure that my temperatures are going to range between 0 and 255, actually even much narrower than that, but this is the smallest type of variable that I can have. So it'll generate the simplest kind of a program. Okay, so how do you put information into a variable? A variable is a storage location, so how do I store something there? Well, you do that with an assignment statement. So in the example above, we're taking, remember how an assignment statement works. It takes what's on the right-hand side of the assignment operator and assigns it to the variable on the left. So in this case, what's on the right-hand side is the value 72. So it takes the value of 72 and it assigns it to the variable desired temperature. In a sense, it's putting the number 72 into this memory location. Okay? You can kind of think of the assignment operator as an arrow pointing left. So on the left-hand side of an assignment statement, you always have a variable name or a port name. And on the right-hand side, then you have the assignment operator, and on the right hand side you can have a value. You can also have an expression, which I'll show you in a minute. Okay, so it says take this value and assign it to the variable on the left. So we kind of read assignment statements from right to left. Okay, don't call this an equal sign. Right? There's going to be a time when we have to say equals in C, and we don't use this symbol for that. We actually use two of them in a row. Okay, so don't get sloppy and call it an equal sign. This is the assignment operator. Okay, and so an assignment statement always has this format: a variable on the left, the assignment operator, and then something on the right. Okay, over here I have another assignment statement. This has a variable called current, and it's being assigned the value of, well, now over here instead of a number I've actually got an expression. So here's my variable name, there's the assignment operator, and I have an expression. Okay, just like in math, an expression is just some combination of numbers and variables. Okay, so in this case it's going to take voltage, the slash means divided by, you know that, right? It's Ohm's law. Voltage divided by resistance, so it takes the value of voltage, divides it by resistance, figures out what that is, and assigns the value to current. Okay, here's making an assignment statement on a port. So it says take this number on the right. Remember what the 0B means? Here, the compiler always assumes numbers are in decimal, so if we want it to be something other than decimal, we have to tell it that. So we tell it it's binary by putting a 0B in front of the number. Okay, and then port A is how many bits? It's 8 bits wide, so we see 1, 2, 3, 4, 5, 6, 7, 8 bits being assigned to port A. So this would go in port A bit 7, bit 6, all the way down to bit 0. So there's the port name. It's on the left-hand side of the assignment operator. You'll never see an expression over here. It's always got to be a variable or a port name because you're putting something into one single location. Okay, there's my assignment operator, and there's the value being assigned. Okay, so brief summary. A variable is just a storage location in memory. You declare a variable by giving it a name and a type, and you assign a value to a variable with an assignment statement. Okay, in our next lesson we'll talk about how to make decisions in the C programming language. See you later.